All right. What's the update with Flaky Jest?
So the update with Flaky Jest. Earlier today, Cos, Mark, and I already prepared a little something. This is the wrong something. So we have a thing, the Jest Speed Reporter, which lay dormant, like it was orphaned, for a few years, and
Yeah.
now we've basically went back and reactivated it. Mark had the great idea that, hey, let's find a commit where two pipelines ran, because one problem that we have is it's not very deterministic on which of the 12 parallelized Jest jobs something runs. So let's try at least to find a commit to see whether the same specs are slow, right? Because one of the things that we saw between runs that actually the specs in the top 100 actually were different. Like some of the specs appeared, but we also had the problem that some of these specs didn't appear in the top 100 of
Yeah.
a different commit at all.
Like it went to the point where in one pipeline, a particular test took like 4 seconds, and in another pipeline, it took like a tenth of a second.
Yeah.
So that is not specific to the test.
That kind of behavior is what I had seen just in passing, and why I was thinking originally this has got to be runner specific, of like the runner is just bogged down. But we don't see this flakiness in our, well, we kind of see some flakiness in our spec, but not to this extent, right?
So we have multiple theories, and let's just jump ahead so that we can do some pairing.
Okay.
So the result of the call was like, hey, because right now we error out if a spec takes if a single it takes 6 seconds or longer. And so one of the idea was, hey, let's just bump it to 10 seconds for now. Boom, right? Like see if the flakiness goes down. I already see Paul screaming. So the other thing that we wanted to
I was going to say
on,
something else related, unrelated, but yes.
So the idea would be we created an issue that we extend this Jest speed reporter to look at the last 20 pipelines, right? And, report on the median of the specs so that we actually can go in and fix slow specs. As an example, for example, this is one of them. This is just slow every time. It's definitely in the top 100, and there's already an MR up to fix it. Okay. Another one of the problems we saw, a lot of the specs that are slow and failing seem to boil down to async imports or just importing a lot of stuff. So for example, even in this one, a lot of stuff is imported. And so we're also thinking maybe disk IO is a thing, because we have 2 CPU cores. And so if 2 Jest runners run in parallel, or two Jest workers run in parallel on the same machine, and on slow HDDs, it could be if they, import stuff and need to transpile everything with Babel, that they kind of go into the nitty-gritty. One theory we had is because we bumped node 20 and the stuff seemed to be a lot more consistent before node 20, that, for example, Babel now compiles different stuff, and that before it was very optimized in Babel. Like, the transpiled version was optimized, but maybe now Node supports like one of those new JavaScript features that is not as optimized in Node, and that might lead to things. Also, garbage collection, like we just don't know, right? And the question is like, is it worth to have red masters and breaking MRs just because we don't know, and this investigation likely needs more time? And that was the reason why we decided to bump and look into extending our reporting here to have visibility on, hey, let's say 20 pipeline runs, or let 20 or 50, 100, who cares? So that we know which tests are actually slow, to look into them, and potentially by fixing slow tests, we also might fix like side effects that happen.
So that brings us, I want to make you mention this. So this copy as JFM, IB made it quick. MR to fix that specs runtime. Now, it fixes it in a way. Sorry, my brain is complete mush today, so you're going to have to bear with me while I try and explain what I'm trying to say. That test was very slow because no, the fix that IP has done doesn't change the amount of time it's going to take to run in the job. All it changes is the recorded time of the it, according to Jest. So we're kind of looking at two things here. One is reported test time, and we don't want that to cause failures and sort of unnecessarily slow down MRs. But also we want job runtime to be reduced. Now, this copy as JFM fix addresses one of those things, but not the other.
Yes.
Have I made sense?
Oh no.
Yes, I think so.
Yeah.
So my concern is, even if we do this, which we're going to do it, but when we do this, you know, if we can fix tests by moving expensive stuff out of its and into before each's or for alls, but that's kind of hiding the problem. There's still going to be expensive work going on for some reason, and that's only visible in the job runtime rather than the Jest reported test runtime.
Yeah. So here you can see what is the expensive stuff that's actually happening in one of the specs. And on my machine, what's funny is we kind of did this in copy GFM already. Like we called the thing once, and then we knew that Jest has transpiled everything and everything is ready, like the async imports. And then, you know, all of these other specs pass very quickly. While interestingly, one of them, like this XSS spec, calls the same APIs as the copy specs under the hood. And so like by just moving this up, this one, what is it? This before all, moving it up, it just makes sure that basically before the first it runs, everything is ready. Yeah. But the problem is we have a few other specs.
And do you feel like is this a situation where async import is relevant?
Relevant in the sense of that it introduces something bad?
No, I meant like, does any of the modules here use async import?
Yes, definitely, 100%. Like,
but I think whether it's async or not is irrelevant. It's still IO that is the problem.
Yeah, we think so as well. It just takes a lot of time to read a lot of files, especially I think the whole tip tab thing.
The async, right? But the async import is important, where it's like that means during test time,
yes,
Jest is doing transpilation and stuff, and
yes,
which used to happen, I guess, somewhat efficiently, is now happening a lot slower.
So obvious thing is we just moved to vtest, so the stuff is done with ES build, so we don't have the problem. But the other thing is potentially.
Wait. What? What do you say?
So there is like.
Wait, I thought Vite was just an experiment, right? We're removing Vite eventually, right?
No, this is basically Jest, but based on Vite, whatever.
Are we doing this for real?
I mean, I don't know, like. Jest never wants to support ESM natively, so maybe.
I see.
Anywho, so another example of the async import is actually, for example, this. Like we added a bunch of specs that test that one of these page entry points that they call render.
Oh yeah, I was just related to this MR. Yeah, is this causing issues?
Yes, because here. With this import.
Oh no, Paul.
I know.
we work on that. And where you were mentioning this, I was thinking like,
So with this import, we're just importing half of the universe and everything, right? And so this might be problematic. And actually, it's funny because because we were able to break this spec as well, right? Like it doesn't even test what you think it's testing. So if we go here and do this,
Yeah,
the
yeah,
spec
yeah,
still
yeah. It'll
passes.
still work. Yeah, 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 yeah. It's
But
yeah,
yeah,
we can remove the tests because we only usually test these page endpoints through like feature tests.
Yes,
so it's
I was looking for the documentation. I think I read a document that we don't test the index.js, but I couldn't find the link and say, okay, well, all right.
I mean, probably all right to actually write a test that just looks at the source of the file. I wanted to parse it, but Mark was like, hey, we can just basically check. We can just basically check like all of these because we have a bunch of these render GFM tests. We can just look with a regex if render GFM is called. And that's probably a lot faster. But yeah.
Well, so but we want to probably delete. This is causing flaky failures. We probably want to delete this test.
Yeah, potentially, but it's also not very consistent right now. Like if you search here, you find a bunch of render GFM, right? Like 6 or so. Right? Like
well,
these are like the render GFMs. And I mean they are not close to the 6 seconds, but like they still take like a second, right? Which is rather long.
Yeah. I think well, I wouldn't like wait. I see what you're saying. Okay.
Yeah. Okay. Long story. I mean, it also could be there's, for example, if we think about 2 workers running, it could also be that one of them is actually taking up all the HDD resources and making another test slow, right? We don't have visibility right now, like in which order did tests run, what runner did they run on, etc., etc., etc. So yeah, one of the things that we just wanted to have a look at was like potentially extending the speech reporter to have a little bit more data. And in the future, if like, certain specs are just very slow, maybe even create automatic issues or something, right? But you don't, because it's so flaky right now, you don't want an issue every time something goes above 4 seconds. You probably want to look
right.
Yeah.
I think we need to get to the root cause of why all of a sudden tests that were not flaking are flaking now.
Oh, the root cause is the update to Node.
That is definitely the root cause.
I mean, so
it's a strong indicator, yeah. Like
it's like so where do I have my so where's the Jest open Node? No, open. What? Did I delete it? No.
More like no modules.
And we have open one of these. I mean, we already have one open, a recent one. So okay, so this is a pipeline before Node, and you can see our copy as DFM candidate is still there. But even just looking at the top 20, you can see that everything is a bunch slower, right? And it's just like, yeah, like we looked at this extensively earlier. We will upload the report.
This is before Node 20, but okay, but is on the right. Is that we would need to see locally after Node 20. We need to see it locally after Node 20 because this is runner time is going to be different, right, than local time.
Yeah, but if you look at it locally, it makes no sense. Like it makes not. Some of these specs are like, okay, they take 40 milliseconds locally, which is long locally, but like given that like you always need to deactivate the Jest cache because
is before Node 20. Is that I see. So this is still runner time. This isn't your test locally.
This is both runner time. This is both.
Oh, I see. Okay. Yeah.
I think the groups represent better the medians, and there are suits that have like 30 tests in them. Maybe that would be a better indicator for us to look at.
So like, for example, look at this pipeline schedules app one. Yeah, so like you can see like 27 tests, right? And here the average I mean, probably should look at the median, but like the average of those 27 tests went up from, you know, 3.6 seconds up to, you know, 0.465. Let's look at another one. This one looks good, has 33. This is about the same, right? It's just, it feels like we are getting more extremes, right? Like on the high end, we're getting more extremes. We don't exactly know why. But yeah, the idea was like, we also just need more insight. And this is why we already spent 20 minutes now talking about it. Do we want to do some coding to maybe look at 10 pipelines rather than just one?
I do want to just clarify what extra insight are we wanting to add? I think that's the bit I'm not sure about.
I mean, the problem is right now we just looked at individual pipelines, and looking at individual pipelines is not very helpful because just the run times are so different. So I think it would make sense to be able to sample like 20 pipelines, and then we actually could sample now, and we could sample before node 20 and see if like how the medians or like how the averages behave like on the top 5 specs, right? I don't know. Right?
Yeah. Do we have one after node 20 that's immediately after node 20? Like, are we sure that there's nothing between
of node 20? Yeah, I mean, we could pull that as well, but like
I'm fine adding you know, more context makes sense. I just I know that like we planning just for a little bit, it's gonna save some executing time. So but it makes sense that we want to comparing individual runs isn't the most helpful. Makes sense.
So I mean, we could even look at if we're getting like the data for the commits, we could even look at 20 before node 20 and 20 after and the same thing. And if we see like, hey, there's a trend that everywhere just goes up or like suddenly becomes erratic, we definitely, I mean, we 97% of the time, we should be very sure that, you know, the node 20 update was actually it, right? And then it might be, you know, lead us to, hey, let's look at, you know, the minor changelog of node 18 versus 20, what happened there? And, you know, maybe
I was looking through all of that. Yeah, and yeah, it's weird and concerning. But yeah,
I mean, there's all kinds of stuff. Like we don't update our dependencies very well. It could also just be like updating JS DOM fixes stuff, right? Like that there are certain code paths now in node 20 that are like, and this is why let's bump the number. Let's, you know, get
so talking about needing right. So talking about needing visibility, it definitely sounds like there's some things we can do to improve Jest Speed Reporter. Is there anything that we can do to improve our Jest jobs themselves to like add some verbosity to like what are they spending time on?
So I've asked a question in runner execution or pipeline execution about getting visibility on IO and CPU contention, because I think that would give us some information. But I mean, we can attack this from two sides. One is in Jest JavaScript land, and one is on the runner side.
Yeah.
And we need to do both. Like Luke's was saying, like computation is cheap. We should just upgrade our runners.
We should also, we probably still need this to Jest Speed Reporter, because if we're doing stuff, it would be good to verify it. Like, I don't know, if you have an MR that creates, like updates JS DOM, you just trigger 20 pipelines and look at it again, right? Like point the Jest Speed Reporter towards that branch or something, right?
It's a great idea. Yeah, I love it. I think it's a great idea.
I think having something like that is useful. Like an aggregate time of the 20th pipelines or jobs that have run in the past, because it can give us a way to monitor not only things that happen with the software, but also with the hardware, with many things, right? And if we see that, oh, actually this number has changed quite dramatically, okay, we can take a look at what has changed. So I think it's good, but I don't think we need to find a very intricate number, but just an aggregate number of the average time that it took for the Jest runs to run in the average 20 pipelines or something like that. I don't know. Am I explaining myself?
I think we want to do the median of the last n, the median of every spec.
Yeah.
Of the last n pipelines. And if the median is above a certain threshold that we set, then we report it.
So you mean you mean when you say median, not the average.
Yes.
You're talking about the middle one.
Exactly, because that's the most. So it all comes back to the fact that this is so variable. You know, we're seeing a 50 times variation in spec runtime between runs. So you've got to ignore the extremes. Because it is just related to IO or CPU contention or whatever. So we have to ignore that, and median is the way to do it.
Okay.
Cool.
Yeah, let's do it.
Let's do it. So let's just. I mean, we have spent half an hour talking, so let's do a speed run here. So what it basically.
No, I feel like we've done a good amount of work. Good job, everybody. This is good.
Yeah, I know. Talking is great. So how it currently works is it just goes through the pipelines, the successful pipelines on master, and it basically, as soon as it finds a pipeline that has Jest jobs, it just returns the results of those pipelines, right? So because we are basically moving from a single thing to an array thing, we probably need to do some refactoring. But maybe let's not break the existing code as is. So I copied the file so that we can go ham on it. Yeah. So let's try and do this. So we still need to iterate over pipelines, right? Master is probably good enough for now. We could make it configurable with a CI parameter. And actually,
we should. Yeah.
Not one status success, but the problem is that the search we would need to filter out by status. So maybe we just do this, and in the pipeline here, we do if pipeline status. I don't know. It's probably something like this, like failed or success. Includes pipeline status, then we are happy, then we want the Jest jobs. And so if we don't have one of those, we just continue, right? Rename get last n pipelines with Jest jobs. N equals 2. Cool. Cool. This is probably going to be an array, right? Pipelines. So pipelines.
I think we should refactor everything into Dino.
You can
no, can we use not Dino, please? Let's use Bun. It's much better.
Oh no, actually I saw this one. Vite Ruby.js.
Oh my gosh. Nice.
Don't be confused about the name.
Okay. I'm already confused.
So Ruby.js Vite, that's it. So there's Ruby.js, which translates Ruby to JavaScript. I don't know why it has Vite in the name. But this obviously makes more sense. Let's just write it in Ruby and then translate it to JavaScript.
Gosh. Oh no.
And then run it like on an AWS worker.
Why the hell would you ever want to do something like that? Like,
I don't know.
Shouldn't the goal be to Ruby to like something besides JavaScript that'll run in the browser instead of
WASM?
Cool.
So found some Jest jobs in the pipeline. I would say we probably, instead of just returning early, we have results equals this. And then we here do results push. And then, you know, if results length,
No, because the Jest jobs are all split up, right? Like we're gonna find multiple Jest jobs, right?
way ahead of you doing that already.
Oh, wait, Jest jobs.
Just it iterates through all the jobs. If it starts with Jest, it adds it to a list, and then it gets the artifacts for the jobs.
Okay. Right.
Cool. Let's try it out. What happens here? Node, and then is it get all the data set. Got data for pipeline, got data for pipeline. So this is just going to take some time because it downloads like 24 Jest
Artifacts.
things.
Yeah.
Okay. So the problem is we have some pipelines that don't have Jest jobs, like the docs only pipelines, or yeah.
Yeah. That would be
Cool.
a really nice feature. We'd be able to search for pipelines based on job artifact.
I mean, we started this video and now it's recorded, so I'm not going to repeat myself, but like I think some of the verify pipeline and CI finders could be better. Cool. Now we have all of those, and we already have cool. So are we interested in the suites at all, or are we interested in the individual jobs? We're probably more interested
I think
in
it's nice how we have it as both, right?
Yeah.
I mean, I think a suite would make sense because
okay.
I mean, ideally both, yeah, but a suite would make more sense because it's file related, right? If we're pulling in a whole tree, that's relevant to the whole suite rather than just an individual spec.
So we are probably able to do this. Pipelines. I don't know. Is pipelines.map pipeline?
I don't want to stop you, IP. So you keep going. But I just had an idea that would probably solve the issue. So I have a strong feeling it's related to the compilation time that happens during an it. And maybe we need to set up our pipeline to just do all Jest Babel compilation in one step and then include that as a cache in all of our Jest jobs so that it just doesn't worry about compiling. You know?
It might be execution too, because I think when we
this is assuming it's not execution, but like I know that I know that the Babel, I mean, Jest will be smart. Like if it finds it in the cache, it won't compile it. But then if it doesn't find it, it'll spend time compiling it. And but yeah, it could be execution time. But if it isn't, maybe we need to make a step to just do all compilation in one step, outside of our Jest tests.
So we now have all the pipelines, like the pipelines, and we have all the test suites and all the test cases. I mean, right now it's named like slowest. Probably we can get rid of the sort, but in the end, sort will be quick. So who cares? So now we basically need to create a union of all these things, right? Yes. So how does stuff look like right now? Let's have a look. So this is how a test suite looks, right? And now we basically average. Now we basically want to time. This time is off. Maybe let's get rid of this one because it doesn't really help at all. Probably would need to sum it up, but yeah.
I think it's off for test suites. Yeah. That's weird.
I mean, I'm doing the average, right? Like find average time. Like this is a nice recursive function. So cases, I have no idea. Anyway,
Wait, why do we need a recursion for finding the average time?
because I think if you look at the XML, that basically every describe is like a test case in like it's nested in XML, right? Like similar to the Jest output if you have multiple describes.
I see what you're saying.
So you need to basically, if you want just the its, if you want to be an it man or an it woman, you need to flatten everything.
I see.
Yeah. But
Sorry, go ahead.
maybe we just flatten it once because the nesting doesn't really matter for us, does it? Like, because right now, like, yeah, let's flatten it once. Let's flatten it once. Let's flatten it once. Yeah, let's flatten this once. So where do we do the parsing of the JUnit files? Cool. Const suite. Oh, so we gained so many useful JavaScript features, right? I mean, we probably wanted to fail if we don't find a suite. Suite test cases equals, is it test cases? Or test case? Ah, it's test case equals let and map cases suite.test case. Cool. Return suite, because now everything is sweet and flat. So we can simplify the average code by sum equals what is the sum? Test case dot reduce, and then we can basically use this, right?
Sounds like we can make a new function.
Yeah, and then average would be time divided by
test cases dot length.
Yeah, find slowest test case. Probably still works, so we can get rid of this complicated thing. We just have one complicated thing, which is good.
Yeah.
Yeah, cool. So here we just need to return test case, which is nice. Sweet. So probably just this, right?
Yeah.
Job JUnit dot test case.
I'm so spoiled. I do, 90% of my development is in TypeScript these days.
Yeah.
And
you want to
no, we keep going. But it's like I'm so spoiled that like all of a sudden we're like changing the return types and stuff. I'm like, oh my gosh, like having to keep all this in your head. I don't normally have to do this anymore. It's really nice when got types.
Yeah, that's true.
We've got an issue about that, haven't we? Should we reopen that?
Yeah, we should reopen that.
Cool. So now we have a list of test cases that are, you know what I'm actually going to do? Let's just sort the test cases here. Because then it would also be easy to get the median if they're already sorted.
Nice.
Yeah. Cool. Now we sort them by average, which is all right. We could also sort them by total time. But now we need to join it from two pipelines, right? So how do we do that? I mean,
so wait, this get test suites from Jest jobs. Is this just one Jest jobs coming from one pipeline, or is this going to be?
Yes,
Okay.
This is just one Jest jobs from one pipeline. I mean, there might be different jobs in different pipelines, so we now need to merge the two, right?
I see. So I would like, what do you think of I was thinking of just adding like another table to the reporter. So like, let's keep the single pipeline reports.
Oh yeah, I
Yeah.
would just like as in quick iteration. That's why I copied the index.js file. I would create like a second HTML file for now or something, right? Like so we don't mess with the existing one.
Okay.
Them later. So how do we merge them now? So we basically be like we basically need like all the data, right?
That is the name of the module.
Yes, all the data, get all the data set. That sounds like wrong English.
All the days.
But anyway, cool. So we would have actually
Yeah,
this
what does this look like? We're looking at
test suite, right? We need test suites, so we just do
so
pipelines.
are we saying every value? So it's going to be the same kind of output where we have test suites and slowest tests, but every value is the median of all the pipelines, is what we're thinking.
Not necessarily all the median for all of them, but like I would love min, max, and median, right? And right now, maybe slowest we can disregard. Like I don't care about the slowest of the suite, but I would probably get the min, max, and the median of the average, right? Like for the suites. And here we do the same.
Slowest is important. Like that's what's going to trigger the flake, right?
Potentially, yeah. But like,
I mean,
I
let's
mean, we
just do
also
it. But
have
that
a
makes
list of
sense.
slowest tests, right? It also could be like what I dislike about the slowest test cases in each suite is you might have a suite that has two very slow things, right? So I don't know. But yeah, I mean, we can just merge the slowest and get like all the slowest. I don't know, right?
Yeah.
So cool.
Okay.
Let's deal with the slowest later, is what I'm saying.
So I
So
almost think then, like, what do you think of at this layer of all the data set when we're combining pipelines? If we have test suite min, test suite max, test suite median or something, and then the shape of it looks the same as like what we just did up there, but we keep the shape the same. We don't have to change like slowest or whatever. We just have a outside of that is our group. We grouped it to do the min, and we grouped to find the max, and we grouped to find the median one, you know?
but we want the min, the max, and the median of each individual suite, right?
Yeah. I'm just talking about just the shape of what our JSON object will look like.
So if I have a table like with the slowest test groups or whatever, I would probably want to have, for example, sign-in page, suite, min, median, max.
Well, is it min of average or median of average? Okay. Okay. Cool. Yeah. That sounds good.
Right. And then what else do we have here in the slowest test groups? The slowest test, I don't know. Yeah,
Even
the
just
median
an
of
average is fine. Yeah.
Cool.
So if you just go back, sorry, if you just go back to the browser there, what test group times 0 seconds? How's that?
Because the test group time that's reported in JUnit is always 0. That's why we actually sum it up here now.
Okay.
Cool. Yeah, so what do? We just go over all the test suites and the shape that we want is like this shape. But the problem is it needs to be, we need to match it with the name. Okay, so it will be an object, that's for sure. We will have the accumulator, we will have the current one, and we just do a comma here. And we just do accumulator current name equals this one. Cool. Const current equals this. No, up wrong. Name.
Eduardo, I just created MR to remove that test. Do you mind if I sign you as a maintainer?
Cool.
Yes, that's fine.
Okay.
Cool. Average is also cool. So we do min average. We start out with this. Then we do max average. I mean, actually, we just need the averages, right? So, yeah, cool. Averages. And we do average. Because otherwise it's hard to get the median. Average test case length we don't need. Slowest. I don't know. Slowest is also an array. Cool. I don't know. Slowest. Tests hopefully doesn't change. I mean, you know, it might be whatever. Time, cool. Here we don't need the current name. So this creates like a new object in case it doesn't exist, right? We need to return the accumulator, and we just do average is actually empty and slowest as well. So we just do act name averages push average and slowest put slowest. Slowest. Cool. Actually, probably like let's do time as well. Time push time. Cool. And then test suites. This is actually not all. All suites equals this.
Why don't you initialize the object in the with all the arrays and just push?
Because like here, okay, because this will be the object will actually be like suite 1. And one of those name
okay.
yada yada. And
yes.
you know,
I see it.
yeah. It's a little bit, so this is more of a
Yes.
of a
It's
map.
a dictionary.
Yeah.
Yes, a map.
So this is why we actually object values now, all suites, right? And then we do a map. And then we have our shape from here. Test is just a count. So our thing here. And we have suite. Cool. Return suite. Cool. Min average would just be math min at is it suite dot averages. The max average would be max, and the median average would be suite averages sort A, B, and then A minus B, and then we want, am I missing something here? Comma. And then it would be suite averages length divided by 2. It's not the exact median because, right, but should be good enough. Which, by the way, will be funny if we only get 2 pipelines. We probably want 3. So that it's just like clear that we have a min, a max, and a median. Yes, and this should actually be it for the test suites. Yeah, let's remove the slowest test here. Let's do this node get all the data. Is it get all? No, get all the data set, right? And then we need all data.mustache. Wait, what? All data.mustache. And what we actually are interested in is the name, the min average, the met
I don't want to
average.
stop. You keep going, IP.
Yeah.
So at the same time of improving, you know, our speed perspective, do we think it would be beneficial for us to have a separate task that does all the Jest compilation and running that before we run Jest jobs?
So
Can you
I've-
do that?
What were you gonna say, Mark?
I was going to say I was looking into whether that's something Jest can even do without
Yeah.
words, and I'm not seeing anything, and I'm just going through the source to see if we can like hack it somehow.
We could hack it. So we could even create like a Jest either in the test setup or a test that imports all of our page entry points. It's weird. And then that's like, then that would compile everything. And then that output in the temp directory, we cache in the job and we pull that cache and all of our actual test runners.
We can't, it would have to be every single file, not just every single entry point, because of async imports, for instance.
Oh, we did something right. Sorry.
But you're right, that is probably a way we could do it. If we just have it import every single file that can be imported,
but I think
just grab the cache directory.
I think Jest, and we can even do that with just the file. Like we can, we're in Jest land, so we could just make the file system read glob all the files and just force Jest to do some compilation step for everything. Because I don't know. What do you think?
It feels wrong to me. Like,
it feels wrong.
Yeah, because in the sense of, hey, you know, the tooling should be able to compile stuff like on the fly, right? Like it's weird to me that this would be a blocker, right? I don't know.
Yeah, I mean, I think it's fair, but I feel like the number of times I felt this feels wrong to me in JavaScript land, I was like, that just feels like the norm.
I mean, I think it'd be interesting to do just to see how long it takes, how much of the job runtime is compiling the module cache.
And like Ruby doesn't have to worry about this. Like, and it's almost no other scripting language has to do this compilation stuff.
I mean, this is a problem with Jest because Jest doesn't understand ESM. I don't think we need to do the compilation stuff per se, right?
We do view files.
Yeah, true.
Yeah.
Actually, a lot of it is going to be compiling view files, for sure. Probably Babel is the easy one.
Yeah.
So are we thinking that the variability here are coming because of the compilation with Babel? Because if that is the case, I think it will be easier to look at individual jobs at the time of the individual jobs, and they should be quite consistent because the compilation happened outside of the the it, right?
I mean, it depends on the order. So for example, if one test, because we have two workers running at the same time, so it could even be, even if the order is the same, that one worker is a little bit faster than the other because of reasons, and it might have compiled something that then the other worker uses from the cache, right? Like, I mean, one thing that we also can do to make it more deterministic is we could reduce the workers to one in CI and just double up on the parallelism, right? Yeah. I mean, we would be wasting one CPU, but we are also doing that in Rails land, so I'm not too concerned. So why is that not this not possible?
Sorry for a noob question. I understand that run in the model would happen in the it, but as far as I understand it, the compilation would happen in the it as well, right? Is this the
Yeah, I think
suggestion?
I think that's the situation that
Because,
concern. But I do wonder.
because
Go ahead. What were you gonna say?
because I assume there would happen a let's say that pre-parsing phase where we would detect all the imports. At least this is how I remember pre-write engines would work. I don't know how Jest works currently. So are we sure that the compilation happens at the it time, not at the
Well, it depends. It depends on the test itself, how it's written. So this copy as GFM thing that we fixed earlier today is an example of this. There's a before all which warms up the module cache for GFM, and it was in one described block, but another test in a different described block hit a code path which triggered this async import, and that particular test was slow. We fixed it by just moving the before all, which does the warming up higher up in scope, and then made the test runtime like drop.
But we are still not sure if it's compilation or if it's execution or anything else. I mean,
it's not 100% sure. We know. Yeah.
Oh wait.
It's
look at this. Look at this issue. For some reason, I must have created this issue a while ago. This is about telling Jest to transpile these dynamic imports at setup time. I wonder if we've run into this problem before. Oh no, they just closed it with no.
What? Why am I have all the pipelines parsed. Cool. They look like this. I go through all the test suites. Cool. And I reduce the test suites. So this is an individual suite. Name test suite. What kind of format I mean, test suites are just like an array of objects. Cool. I mean, I'm just going now. Console test suite. If I only had something like types here. Oh, we're at time.
Yeah, it's okay.
I'm a little confused, by the way, because I thought that Jest is running tests in a file in order, but it actually runs the files out of order.
Yes, because it parallelizes all of its runs. It uses a bunch of CPU cores, and I think that may also be related. I was going to say this, that may also be related to the compilation, because I wonder if the compilation happens in a different thread, and for some reason, because of whatever's happened with runners, that takes a long time while it's just waiting for this other thread.
Well, also maybe there's an ordering issue. Yeah, like if one thread does a test run that warms up the module cache for a different test.
100%. Yep, 100%.
There is in theory an ordering which is the worst possible ordering, right?
Yeah,
and a best possible ordering. So yeah, you've kind of nerve smacked me with this compile order. Yeah. caches.
I mean,
thing.
if we this is what I mean. Like, if we were to run everything in band just on one worker, the order would probably be defined, and we might be able to track down what the problem is, right?
Right, but I'm not interested. Like we could, but I'm not interested in like we're gonna fix every single one of these tests and future tests that have this like async import that sometimes causes flakes stuff. I feel like in every other language, you're gonna compile everything and then you're gonna test it. It's a bit weird in JavaScript land that, and especially in Jest, is contributing to the problem that compiling is happens at test time sometimes. That's definitely gonna cause some flakiness.
I mean, do others have like just async import compile bubble?
Yeah, I just linked to an issue. We must have run into this issue in the past. And in 2020, I created an issue saying like, hey, could Jest figure out that it needs to compile these things ahead of time? But no one hopped on it, so it just died.
Yes.
Oh, you got the outputs. Nice, cool. Yeah, that's gonna be helpful. Well, I've got to hop off. But I think I'm gonna time box myself and see if I can create an experiment to see what it would look like to compile things ahead of time. If I
I'm sorry. I've already started doing that, Paul.
okay, all right, that's fine.
But I mean,
So
I
I'll
don't want to
find
ruin
some
your fun.
other OKR I gotta work on. I don't.
So this is already interesting, just with 3 pipelines.
Yeah, that's a big spread.
I mean, these are now the same at the moment because probably rounds the wrong way. But like,
How long did it take to collect this information?
I don't know, 5 seconds,
Okay, then
10 seconds.
can we get a larger number of pipelines?
Sure, but the suites by which should be sort by median average?
I would say median, yeah.
Mark, feel free to if you want to collaborate on the thing together, whatever you find, or if you have any code to push up, we can push up and work on a branch together, or I'll create an issue. So just feel free to ping me on.
Will do. I'll make an MR and ping you on it.
Okay. All right. Well, thanks everybody. This is fun. I think when I leave, it'll also stop the recording. So
You can make someone else the host.
will that keep the recording going?
Do you record to your machine or to the cloud?
I think I'm recording to my machine, so no, it won't, would it?
Okay.
All right.
Yeah, cool. Then
Bye.